Hello guys, I am Nidishri Swagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we discussed regarding the chemistry topics like acids and bases, chemical reactions and equation, as well as metals and non-metals, right? So in the metals and non-metals, we learned the properties of metals, properties of non-metals, and also we discussed regarding the chemical properties of metals. And after that, we learned regarding a special kind of compounds which are called as ionic compounds. Right. So when you recall how the ionic compounds are formed, so these ionic compounds will be formed by gaining or losing electrons. Why they have to gain or lose electrons? They have to gain or lose electrons so that they will get the octet electronic configuration. Means the nearest noble gas configuration so that they will become stable, we can say, right? They will become stable. So for this, the ionic compounds will gain or lose the electron. And thus that gaining and losing electron creates a bond between the atoms, which is called as ionic bond. And when you consider the melting point and boiling point of these ionic compounds, let us say sodium chloride is the ionic compound, right? So the sodium chloride melting point, the sodium chloride melting point is found to be 1074 and the boiling point is found to be 1686 Kelvin. When you see the melting and boiling point of the ionic compounds, they are high. And we know that these ionic compounds are good conductors of electricity in aqueous solution as well as in molten state. You can think why ma'am is telling about ionic compounds as she is going to start a new chapter, which is writing. To learn this, we need to learn this, means we need to recall so that we can compare. So let us now do some small activity, guys. Let you consider a tabular column. Consider a tabular column. Okay. So in this tabular column, first you write the things around you which are made up of metals. And you just observe the things around you and note down which are made up of glass or clay. And others. Others means which are not made up of these two, which are made up of different material. Fine. So here, when you consider the things made up of metal, so I will list out what are things surrounding me. So I have a table fan, and I have the tripod stand here. My study table I have, which is of iron, and the windows bars, which are made up of iron. Okay. Then, oh yeah, only these things I have in my room. Now, let us consider which is made up of glass or clay. So, any items I don't have anything over here. Then I have a vase, which is made up of clay. Window, which has a glass, and nothing I have here. I have certain experimental equipments which are made up of glass, like test tubes, beaker, etc. And others, when I saw, I have a duster which is made up of wood. Okay, I have a board. Then I have certain show plants which require very less water. Then I have a small aquarium in my room. Then the marker. So these all are the other things which I have in my room. So when you see the things of metals and glass and clay, and when you see the other things like duster, it is made up of wood. and a form of a cloth or a fiber on it. Then board. So I usually we be having a kind of wood over here and the fiber. Then plant that I said show plant, aquarium I have marker, ink. So directly or indirectly, all these materials which I have noted under other things are made up of carbon guys. These are made up of carbon. It is not completely carbon, I can say. These are made up of carbon or carbon compounds. Ink, it is not completely carbon. It is made up of one of the carbon compound. Wood. So when you burn the wood, you will get the ash. That is nothing but a carbon. So we should remember that each and every living matter, suppose you consider a plant, animal, human being, anything. So each and every living matter, the organic matter will be consisting of carbon. So we know that in atmosphere we have 0.03% of carbon, whereas in earth crust we have 0.02% of carbon. So when you see this value is very small, guys. But whatever we are using the things, whatever we are seeing the living beings or the organic things, so those all are the components of carbon. So carbon has an immense, what we can say, usage, immense advantage in our daily life. Okay, it is very important, we can say. Suppose if you consider DNA, the genetic material of living organism, deoxyribonucleic acid. So this is also made up of carbon, right? When you consider simple sugar like glucose, photosynthetic product, C6H12O6. So it is also made up of carbon. So like this, almost all the substances around us are directly or indirectly have the carbon in them. That is why carbon has a capacity to form crores together of compounds. So it is called as a special type of an element. That is why we have a whole chapter which tells us about the special character of the carbon. So let us discuss regarding carbon and its compounds. Okay. So here, as I said, so we are going to discuss regarding the carbon and its compounds. As I was saying regarding ionic compounds. So when we compare ionic compounds and the carbon compounds, let me take a carbon compound like acetic acid. So its formula is CH3COOH. Chloroform. So its formula is around CHCl3. So when you consider these, so its boiling point and melting point. The melting point of acetic acid is found to be 209 Kelvin and 391 Kelvin. Similarly, the melting point of chloroform is found to be, I think, no, it is 290. This is 209. 209 Kelvin, the melting point of chloroform. And the boiling point of chloroform is found to be 334 Kelvin. So when you compare the melting point of the carbon compounds and the melting point of the ionic compounds, you will get to know that the melting point of carbon compounds are low. So usually the first property is carbon compounds have low melting and boiling point. Okay. Similarly, we know that ionic compounds are good conductors of electricity in case of aqueous solution or in the molten state. So, but usually the carbon compounds are poor conductors of electricity. So these are the two main properties of the carbon and its compounds. You might ask me, ma'am, how can you say that carbon compounds will be having low melting point and boiling point? What is the reason for it? Or why carbon compounds, it is not conductor, I just rectified. It is carbon compounds are poor conductors of electricity. How do you say that these are poor conductors of electricity? How do you justify these properties? Let us see into it. So here guys, as you know, ionic compounds are good conductors of electricity because they will be having charged particles. Charged particles. So we know that anions, negatively charged particles, and we have cations, positively charged particles. Fine. So when these compounds are dissolved in water, so what happens here? There will be release or a formation of the ions. Means the ions will be released. The compound will split up so that the ions are released. Charged particles are released. The movement of these charged particles conduct electricity. Okay. So here main thing is how this ionic compound will get charged. I mean, how they will become anion and cation. Just recall the concept, guys. Yes, you are right. So here they will get charge on them by losing or gaining electron. So what is the purpose for losing or gaining electron? That is nothing but to get octet electronic configuration. To get octet electronic configuration, these compounds will lose, these atoms will lose or gain electron so that they acquire the charge. So due to the charge, they can conduct the electricity in aqueous solution or molten state. But here what happens, guys? When we consider the atomic number of carbon, so carbon atomic number, that is Z, is equal to 6. When I want to write its electronic configuration, KLM, let me write 2 it takes and it takes 4, right? So here number of protons is equal to 6, number of electron is equal to 6. We know that protons positively charged. So here to become octet electronic configuration, to become octet electronic configuration, to become stable, what happens here means the carbon needs 4 more electrons. Otherwise, it has to lose 4 electrons. Otherwise, it has to get 4 electrons to become or to get octet electronic configuration. To get the electronic configuration of a nearest noble gas, that is neon. Atomic number is 10. So here, if carbon want to lose 4 electrons, if carbon want to lose 4 electrons, so when it loses 4 electrons, it becomes a carbon 4 plus, right? So losing 4 electron is not easy, guys. So what happens here? It needs enormous an amount of energy to lose 4 electrons. It needs enormous amount of energy. Enormous amount of energy is needed to lose 4 electrons. Suppose we will take the alternative, means getting 4 electrons. If it gains 4 electrons, what happens? See here, if it gains 4 electron, it adds up 4 electron plus 4. So it becomes 10 electron. And in the nucleus, we will be having 6 protons. It will be very tough for the protons, that is for 6 protons to manage 10 negatively charged particles. It has to manage, the force is there between the proton and the electron. We know protons will be in the nucleus, electron will be revolving. So if the number of electron increases, this positive charge should get sufficient energy, sufficient force to control the electrons. So if electron number increases, proton number are less. So how can it control? How the electrostatic balance, force balance will be managed? So it is very tough for 6 protons to manage 10 electrons. Okay. So here to become C4 minus, so 6 protons, 6 proton cannot cope up with added 4 more electrons, that is total 10 electrons. Electrons only added, no? Protons are not added. So here, it is not possible for the carbon either to lose electron or to gain electron. So it will not gain or lose electron. When it will not gain or lose electron, what happens? When it is not gaining the electron, when it is not losing the electron, what happens? Carbon cannot be an ion or cation. That is, it cannot acquire a charge. When there is no charge, no electricity, means no moving of charged particles in the aqueous solution, no electric current will be conducted. So like this, electricity, that is carbon, will be poor conductor of electricity. Okay, now we proved the second point. Now, carbon compounds have low melting point and boiling point. How can we prove this statement? So here we got one confirmation that carbon cannot gain or lose electron. So that is why it cannot conduct electricity. It will not be anion or nor be cation. Then how the electron will acquire the sufficient bond formation with other atoms? How the electrons will be gained or lost by the carbon? So instead of losing or gaining electron, carbon becomes friend of everyone. So how it acts as a friend of everyone is, it shares the electron. It has a capacity of sharing the electron. Sharing is caring. So when it shares, it will form number of compounds. That is the reason, as carbon has a capacity, has an ability to share the electron, it can form crores to crores of compounds. So almost all the materials are made up of carbon. It is because of this. It has a capacity of sharing the electron. So let us see what is that sharing electron phenomenon is. How carbon shares. Whether we have any other molecule which shares the electron in our atmosphere. Let us go deep into that. Okay, just a minute. Fine. So here, as I said, carbon shares the electron. So before going to the carbon, first we will get to know the other molecules which are there in our atmosphere by sharing the electron. The simple molecule we will consider. So let us consider hydrogen gas. So you might remember whenever we write hydrogen, we will write as H2. We will write in the form of a molecule. We will not write in the form of a H or an atom because it is unstable. It is highly unstable. Then how H2 is formed? How H2 molecule is formed? Here, hydrogen is not gaining or losing the electron. What is happening with H2 molecule? It is also following the same method like a carbon. So here, let us see how the formation of hydrogen molecule takes place. Formation of hydrogen molecule. Fine. So hydrogen, that is Z is equal to atomic number is 1. And when we come to the electronic configuration, KLM. So K, it has 1. We don't have any other electron. So here, to get octet electronic configuration or to attain the nearest noble gas electronic configuration, hydrogen needs one more electron. Helium, the atomic number of helium is 2, right? It has a completely filled outer valence shell. Outer shell, valence shell is completely filled. K shell is completely filled for helium. So this hydrogen will be trying to attain that configuration, that helium configuration. So to attain helium configuration, it needs one more electron, right? So here what happens? Hydrogen will plan something. It will combine with the, it will combine with the one more hydrogen atom which requires electron, So here hydrogen we will draw, two circles, right? Hydrogen, let me draw this. Okay, so here hydrogen has how many electrons are there in outer shell? One electron, right? Similarly, one more hydrogen atom is there which has one more electron. One electron in its outer shell. So both hydrogen need one more electron to become stable. So what these hydrogen atoms will do? They will share the electron. This electron, the electron of this will be shared by, the electron of this will be shared to this, the electron of this will be shared to this. So this hydrogen atom will be also having 2 electron. And when you observe, this hydrogen atom will also be having 2 electrons. See, right? So what happened here? Hydrogen molecule is formed. Hydrogen, HH. As they share 2 electrons, so one bond will be formed between them. One pair of electron they share, na? So one bond. So the bond between the atoms which will share the electron, that bond is called as covalent bond. That bond is called as covalent bond. So what is covalent bond? The bond formed by sharing the electron is called covalent bond. So hydrogen molecule is formed by the covalent bond. Let us see other example. One more example which we will use in our daily life. Usually formation of oxygen. Right. So when you are writing oxygen, you remember that we will write as O2. We never write as O something. Always. We always write it as O2 in a form of a molecule. O2 is a molecule. right? In a form of a molecular form, we will write formation of oxygen. So here, let us take oxygen atomic number is 8. Electronic configuration KLM. So 2 is there and 6 is there. So to become or to get octet electronic configuration, what happens? It needs 2 electrons. It needs 2 electrons. So here, what happens actually? Oxygen will be there. Let us take oxygen. Oxygen atom. So how many electrons will be there? Outer shell, it will be having 1, 2, 3, 4, 5, 6. So here what happens? One more oxygen atom will be there. Okay, so it will be also having 6 electrons. So both the atoms are in need of 2 electrons. Both the atoms are in need of 2 electrons. Okay. So what happens here? Here, 2 atoms of oxygen. 2 atoms of oxygen. Okay. So here what happens? See, 1, 2, this circle you see. When you observe this circle, the atom of this oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, when you observe this oxygen atom, you have 1, 2, 3, 4, 5, 6, 7, 8. So both of the atoms got 8 electrons in its valence shell, in its last shell. So both of the atoms acquire octet electronic configuration. That is why oxygen molecule is stable. Why? Because it has octet electronic configuration. Oxygen atom is unstable because it does not have octet electronic or completely filled valence shell. Last shell, 8 irbek. Valence shell should be having 8 electrons. Then the atom is stable, we will say. So here, oxygen molecule is formed by sharing electron. As you can see that 2 electron means 1 pair, 2 electron means 1 pair. It shared 2 pair of electron. Therefore, oxygen will be binded, oxygen atom will be binded to other oxygen atom by 2 covalent bonds. 2 covalent bonds. Right? So this covalent bonds, what they will be? The covalent bonds between the atoms will be strong. But see, intermolecular, this is one oxygen molecule, this is one O2, this is one O2. The bond between these two molecules will be there, na? It will be very weak. That is why they will be having very low melting point and boiling point. Compared to ionic bonds, covalent bonds will be weak. That is why they have low melting point and boiling point. Okay, so carbon also forms covalent bonds with other atoms or with the same atoms. So this covalent bonds will be weak than compared to ionic bonds. That is why carbon compounds will be having low melting point and boiling point. So in this session, we learned regarding covalent bond formation and how to draw the electron dot structure of the molecule. In the upcoming session, we are going to learn again 3 more examples of this type, and then we will learn about some versatile nature of the carbon. I hope that concept is understood. Today we will end up the session. I will meet you in the next session. Until that, take care. Have a nice day.